So the topic of today's video is, can you weld exotic metals like titanium and stainless steel with a sub $600 welder? Well, we're going to find out.
Don't worry about that, little guy.
Okay, so the welder that we're going to be using today is YesWelder's YWT-200DC. It is a DC-only TIG welder, which means it's great for doing stuff like mild steel, stainless steel, titanium, and things of that nature. Ferrous metals, basically. We're not going to be able to do any kind of aluminum or magnesium or anything like that with it. However, we will be able to weld our titanium and stainless steel with it, no problem. Now, we're starting out with the base model, which is $5.99 on YesWelder's website currently. The YWT-200DC comes along with two different torches, a number 9 torch and a number 26 torch. The number 9 is a much smaller torch designed for low amperage stuff like sheet metal and mild stainless steel and stuff like that. The 26 is designed when you get up into the 200, 230 amp range. This machine will weld up to 230 amps, which is amazing. So what we're going to do today with this machine is we're going to see how well this machine can weld are expensive metals. Now, titanium is extremely expensive. This piece that you're looking at right about here is about, I don't know, $35 to $50 worth of tubing, and it's only about 1.5 feet long. Stainless steel, obviously a little less expensive, but again, just as important to weld it well so that you're not wasting material. So now I want to go through what I did to this machine to be able to weld this stuff. Now, I went ahead and bought the optional foot pedal for this machine, which adds about another $100 to the cost, so you're looking at a total of about $700. We're running pure argon. Tanks are just over there, you guys can't see them. And we have changed out the factory consumables on the torch to a much larger gas lens with a massive gas cup from Mike Furick. So this is the Furick BBW glass. It is a 1-inch cup, which is going to give us the ultimate in gas coverage. Now, before we start welding with this thing, and we're going to go through the setup next, but the reason I switched out to a gas lens in this cup is because these cups actually give you, these cups will give you a cloud of argon shielding your part. Now, the cups that come along with this thing actually create a stream of argon. Now, when you're welding any kind of a reactive metal like titanium or stainless steel, argon coverage is ultra important. So versus having a stream of argon coming out, this large cup and the gas lens will create a cloud of argon around the part that you're welding, which will allow you to weld a little bit further at a time without having to worry about gas coverage. So you'll see that when we start welding the stainless steel and the titanium, that gas coverage is extremely important. On the titanium, we're going to go over what happens when you lose gas coverage, and we're also going to show you guys how to back purge things and whatever else. But main focus right now is, can you weld these materials with this welder? So what we're going to do is dive down and we're going to go through each and every process that we need to do to set this up to weld these different metals. Okay, so first things first about this machine. This machine, like I was saying before earlier in the video, this is the YWT-200DC. This machine is designed for DC TIG welding only. There is no AC. With that being said, you can weld anything in the steel family, you can weld anything in the titanium family, but you're not going to be able to weld aluminum or anything of that nature. So this is a DC-only welder. Now, this welder is capable of doing stick welding, high-frequency TIG welding, and lift TIG welding. And that setting is available right here in the weld mode. If you hit lift TIG, it'll go to lift TIG, and then everything down here starts blinking because none of it is utilized. Stick welding, it'll show you arc force and hot start availability, and then when we go back to high frequency TIG, some of that stuff disappears and it lets us know that all that stuff is activated again. So super nice setup. I love this little color LCD screen. It's so nice. Then you have your torch mode. We have 2T, which if you guys are unfamiliar with that, 2T is when you push the switch on the torch, you start welding, you let go of the switch on the torch, it stops welding. In 4T mode, you push the torch switch and let it go, and it starts to weld, starts the arc, and you can continue welding without having to hold the switch. To stop welding, you either break the arc or hit the switch again and release it, and it'll stop. We're going to be using foot pedal control. Now, the advantage of foot pedal control over a torch switch is that with the torch switch, your amperage setting here is what you're going to get when you push that button. When you push that switch on your torch, you're going to get 70 amps all the time, no matter what. Unless you go through some settings and play with it, but we'll show you that too. So, with a foot pedal, you're going to be able to tap that pedal, start off at a very low amperage, and then raise and lower the amperage between roughly 20 and 70 amps by utilizing the foot pedal. Now, this gives you the greatest amount of control when it comes to TIG welding, and I highly recommend that if you purchase a TIG welder, any TIG welder for that matter, doesn't matter whether it's YesWelder or any other of the big names, you're going to want to make sure that you get one that is foot pedal compatible, because a torch switch is great for doing quick little repairs or even using the cold spot function that this welder has, but it's not great where you need a ton of control, and we're going to need a ton of control over our heat input when it comes to welding things like stainless and titanium. If you were to weld at 70 amps constant, you would blow a hole in it. You set it down too low, you're going to have to wait too long for the puddle to form, and you're going to put too much heat into the actual material. So super important to have a foot pedal when you're welding this kind of stuff. So let's go through some of the settings that are available when we're in DC TIG mode right now. If we push this button, we have various settings. Right now we have a pre-gas setting. The pre-gas setting on this welder, what it does is it allows the flow of argon for a specific amount of time before the arc starts. And with myself, I always set these to about a half a second. So a half a second before the arc starts is when your pre-flow will start the flow of gas, and then the arc will start. Now the next is the current, your welding current. So currently we have it set at 70. We're going to leave it set at 70 because that's where I want to weld. That's where I want to have. Now with the foot pedal, I can control from, it's roughly 20 amps on the start to about 70 amps total with the foot pedal, going from 20 to 70, and anywhere in between that I want to push, I can push. The next one is your post-gas. Now, post-gas controls how long the argon flows after the arc stops. That's one of the most important things that we can do with argon, is make sure that as your part is cooling, that we're covering that particular area with argon. In any reactive metal, such as titanium and stainless steel, what tends to happen is as the metal is cooling down and it's above a certain temperature, it will oxidize, and it will cause all sorts of issues to happen within that weld. You'll get porosity, you'll get poor weld adhesion, you'll get poor penetration, and you could potentially just completely destroy both the weld and the integrity of everything that you just did. So it's just extremely important. Now with titanium, we tend to use a high post-flow rate, like 15 seconds, sometimes 20 seconds, depending on the thickness of the material and how hot it stays for how long. 15 seconds is a pretty good rule of thumb for titanium. On stainless steel, I usually run down at about 10 seconds of post-flow. So welding these metals, you're going to say, wow, that's a lot of gas flow, and it is. We've got a huge cup. We're running at about 35 CFH of gas flow on the regulator, and we're going to be flowing a half a second before the arc starts and 10 to 15 seconds after the arc finishes. So it's quite a bit of gas being used. And that's one of the unfortunate downsides of welding stainless and titanium, is that you're going to end up utilizing a ton of argon. And I don't know if you guys have ever seen it, but I literally have two massive 300 cubic foot tanks to keep up with the amount of argon that I use. And also, too, when we do the titanium, you'll see that you have to purge the inside of the titanium as well. Otherwise, it doesn't weld correctly. So that is your foot pedal mode on high-frequency TIG. Now, if we switch to 2T, we get some more options here. We get a start amperage, which, again, is 20. We can run that down to 5 amps. I usually leave it at 20. Then you have a slope up. Now, this is the amount of time that it will take this welder to go from 20 amps to 70 amps. So when you push the switch on the torch, what's going to happen is it's going to take 3 seconds, which is where we have it set. It's going to take 3 seconds for that amperage to go from 20 to 70. So that gives you a little bit of time to kind of get yourself situated, get the puddle started, and get moving before, you know, things start to go south. And that's again, the problem is you don't have full control because you're not utilizing a foot pedal, you're using an on-off scenario. Then we have our downslope. Downslope does the same thing. As soon as you let off of that switch, you'll get a nice downslope to avoid, you know, little crater eyes within the material that you're welding, because if you snap the arc off of it too quickly, it can cool too quickly, leave a little crater eye, or it will crack the weld depending on what you're doing. So downsloping from 70 to 30, again, or 70 to 20, again, it'll take 3 seconds. Then our stopping amps, 20, so same thing as our start, just in reverse. And then again, we also have our post-flow, our pre-flow, all that other stuff. Same thing goes for 14 mode, no difference. And then back to our foot pedal mode, where we literally have our post-flow, our pre-flow, and our amperage. So now another nice feature of this particular welder is we have a Pro specification button. This Pro specification button allows us to switch between straight DC and pulse mode. Now pulse mode is nice to have, especially when you're doing thinner materials. What pulse mode will allow you to do is it will allow you to pulse the current on and off in a given time frame so that you're not introducing a ton of heat into the part that you're welding. And when you're welding some parts, it specifically may call for you to not input a ton of heat. Chromoly tubing is one. When you're building roll cages, chromoly tubing has to be TIG welded if it's to be certified properly. And there's a certain amount of heat that you're allowed to put into chromoly tubing before it gets too brittle. So you can't just go in there with 150 amps and hog in some, chromoly tubing. You have to make sure that you're welding it properly. And to weld it properly, you should probably use pulse to reduce the amount of heat. So that gives us the option for pulse current or background current. This is when the pulse is turned off, it will go to that background current. So most times you don't want to go as low as 20 if you're running at 70. You'd probably go about half. About 50% is the average. So if we're welding at 70 amps, we want our background current at 35 amps. And then we also have our pulse frequency. So this is in hertz, meaning that 1 is 1 pulse per second. And this would also be 3 pulses per second. So you can set that up based upon the type of material you're doing, how comfortable you feel moving. 1 pulse per second is kind of nice, or 1.5 pulses per second is kind of nice, because you have enough time to dab your material in every time that the welder pulses. And maybe we'll check out a little bit of pulse on this machine when we're doing the stainless steel. And I'll show you guys how that works. So that is pretty much the features of this particular welder. So now we're going to utilize those features that I just showed you guys, and we're going to go ahead and we're going to weld some stainless steel. So we'll go through the pre-flow, the post-flow, and we'll just see how we do. So now we're ready to weld this stainless steel. We're going to weld a piece of stainless tubing to a stainless V-band. Now we've got the machine set at 85 amps, and the reason I did that is because the material for the V-band is a lot thicker than the tubing itself. We're going to need a little bit of extra heat in the beginning to punch through all that and get everything warmed up. And once we get everything warmed up, we'll be able to lay a nice bead in there. So if this welder is actually, if the arc is stable enough, we'll be able to lay down a pretty nice weld with this thing. So I'm going to go ahead and do that. Another key to TIG welding is patience. You need to be very thoughtful and very methodical, and take your time, because if you don't take your time, you're going to make mistakes. Now, one thing I've always got to tell myself is that not to get greedy. So by getting greedy, I mean that basically, if you're in a position to weld out further than you think you can, and to go further around than you really want to, you got to remember the back side of this cup is where your gas is going to end. So if you go past that point where you can no longer cover that weld, and you can see the weld that we just did here is about as wide as that cup. Now, if we go any further than that, we're going to be leaving the backside of that weld out of the argon flow. And when we leave it out of the argon flow, we're going to cause problems. Either we're going to get a ton of coloration that we don't want, or we're going to get it grayed out, which means that basically we didn't have enough argon coverage and our weld is compromised. So you're going to want to go slow and steady, weld about an inch, inch and a half at a time, or whatever you're comfortable with, and then your part will come out good. So again, we'll start it up, low amperage, we'll raise it up, get our puddle started, and then we'll start adding our filler wire. And then as things heat up, we're actually letting off of the pedal just a little bit to be able to control that heat input. And then you'll notice, after I get done welding and the arc stops, I let that argon flow over top of the material to keep that weld puddle cool and covered in gas until the part cools down enough to where it's not going to react with the open air. So let's go ahead and weld the rest of this, and I'll show you what it looks like when we're done. Alrighty, so now we have our tubing welded to our V-band, and you guys could probably see some of the coloration in there. Okay, so that is what it looks like, or what it should look like when you've done it properly. So you can see we got nice penetration. We didn't kill the edge of, wow, it's hot. We didn't kill the edge. We didn't undercut, we didn't overcut, so we're looking good. So now that we got that all welded, you can see how nice that welder does if you use the proper technique and the gas and the setup and everything else. That's all hugely important. So you can see how good that one came out. Now what we're going to do is I'm going to flip this over, and we're going to weld the other side of it with this other V-band, and we're going to do it wrong, which I hate doing because it comes out like absolute trash, but I want to show you guys what happens when you do it improperly. So what we're going to do is we're going to flip this thing over, and we're going to set up on it. And what we'll probably do is I'll turn the post flow almost completely off so that our gas coverage is compromised. And then what we'll do is I'll pull the little piece of paper I got covering the vent on the side of this welder off. We'll see what happens when you get a little bit of air contamination or a little bit of wind when you're trying to weld stuff. So let me go ahead and turn the post flow down to 1/2 a second, and we'll run a quick bead. Okay, so now that's with our post flow at 1/2 a second. And I'll show you exactly what's going on here. That's still really hot. Should probably not grab hot things that I just welded, like I tell everybody else to do. Okay, so what you can see there is you see how over on the left-hand side of that weld, it turned like a dark gray color? That weld is compromised, significantly compromised. We started out good with a little bit of color, and then our weld got compromised. So that weld is not going to be as strong because it is oxidized. Now, not only does it look bad, but strength-wise, it's not great. So now what I'm going to do is I'm going to continue from that point, but we're going to take this piece of paper right here off the side of the welder and expose that vent, which blows air directly on the part that we're welding. So we're going to go ahead and weld that, and I'll show you guys what it looks like when you've got air contamination. You'll be able to see the difference in the weld too, because it'll start spitting and popping and doing all kinds of stuff. All right, here we go. You can kind of see the arc fluttering because we're blowing out our argon. There's a couple of sparks right there. There we go. Then we'll pull the gas away from it. So now this weld is going to look absolutely horrific. Look at how bad that is. Look what it did to the metal. It undercut the tubing. It also undercut the V-band. And we've got all sorts of issues going on in there now. Absolutely terrible. So now what we'll do is we'll correct all of our issues and we'll start over again and see how the weld comes out. Alright, so now what you guys can see is that we brought that right back around again. We brought it right back around to where we need to be after solving our issue that created that mess. And now we're right back to normal again. So I'd say that this little welder is doing pretty good. So I'm going to go ahead, just for S&G, or poop and laughter, go ahead and finish up welding this guy, just to maintain my practice. And that's another thing too, guys. This doesn't come overnight. This takes time and more time of practicing and utilizing scrap metal. And you know, all of these V-bands that I have are just scrap V-bands that I had laying around. I don't actually have the clamps for them. I just have the flanges, and which, you know, in the future if I needed them I could reuse them. But we're going to go ahead and just weld these out so that I can keep myself in practice, because as you guys know, I do a ton of Jeep stuff with MIG welding, but I don't get a chance to TIG weld that often. So anytime I get a chance to do a video and TIG weld, it's a good chance for me to practice and practice and practice. And I try to practice as much as humanly possible to keep my skills up, because it takes me a while to get back into the swing of things when I don't. Alright guys, so here's the finished product. So you can see where we truly messed that one up badly. And then we got much better. As we went along, things got really, really good towards the end there. So as I was getting used to my groove again, started getting better and better. So again, practice makes perfect, and your setup and your gas flow are extremely important. All right, now let's get to some titanium. This nice stuff right here. we'll get to welding that stuff up. That stuff requires a ton of argon. So let's go. We managed to somehow corrupt the card, and I don't know if that was due to the fact that we had this thing sitting on top of the welder, but we lost all the initial footage. So what we're going to have to do is weld up this titanium and figure out how to salvage the rest of this video. Okay, so titanium being a super reactive metal, we have to make sure we have plenty of argon coverage. And what you guys can see is that in the end of this tube over here, there's a yellow plug and there's a hose that runs out of there. Now what we're doing is we're feeding argon into the interior of this piping, to which it is then coming out of the end right there, that plug. So now we have full argon flow on the inside of the pipe. We're going to have argon flow on the outside of the pipe with our large gas lens, and we should be able to make this look pretty cool. So we got the machine set at about 70 amps. I'm going to go ahead and start welding this stuff, and hopefully we don't end up corrupting our memory card again, because now we have to go through everything we just went through, and I don't get to show you guys the cool intro. But we'll figure it out. We'll make it happen. It'll be a little out of sorts, but we'll make it happen. Here we go. Alright, so we kicked the post flow up to 15 seconds because I was noticing we're not getting quite enough post gas. We also had a weird breeze coming from somewhere that I couldn't find. So now we're going to weld the other side. So titanium is funny because you can only go about an inch at a time, which is about what my cup is right here. It's an inch wide. So without taking the gas coverage off of it, I can only weld about an inch at a time. So it's a super, super slow process unless you invest in a trailing setup to where you can actually trail argon behind your torch as you're moving. And then you can go a little bit further, but you still don't ever really want to get greedy with this stuff, because the second that you start getting greedy with it is when you'll start having an issue. And by getting greedy, I mean, you know, trying to go further than you can, or further than your cup distance. It's going to make a huge difference. You're going to end up with issues. And the weld just overall isn't going to look that great. So that was the first one we did, and you can see by the coloration of it that we didn't have enough argon flow on our post flow. You can see all the little spots where we came out of the argon flow. On this one, at 15 seconds of post flow, much cleaner. We got one little spot there, and we got one little spot there, and one little spot there. But this whole section here was much better, and you can kind of see the cool little effect that it has when you weld it. And I can't believe this stuff is so hard to film. It's unreal how difficult it is. I mean, you can see how many different ways it changes under the light and all kinds of other stuff. It's a really cool material, but it's really, really difficult to weld well. So, I mean, this will hold. It doesn't look the best, but it'll hold. And we did it with a sub $600 TIG welder, guys. So, I mean, can you weld exotic metals with an inexpensive welder? You absolutely can. Alright, so like I was saying with the stainless steel, the titanium welds definitely take up some practice and some gas flow and some knowledge and whatever have you. So you're going to want to make sure that you have your gas flow set perfectly, because you can see we had a little issue right there where our gas flow blew away. And then in certain areas of this, you see where there's some blue there. That blue is not good. Acceptable in some cases, but not most. You want to have a light straw color or silver completely. So on that particular weld, we didn't do all that great. On this weld, however, we have pretty nice straw color all the way around that bead. And that weld actually came out pretty decent, with the exception of two little spots that had some color in them where I got a little greedy and I went too far and it came out of the argon coverage. So the titanium stuff, it's ultra important that you're utilizing every bit of the argon coverage that you have. I mean, technically, if you welded this in an argon chamber, you'd probably be better off, but that's not always feasible. So you need to make sure that you have a ton of argon coverage so that you don't end up with artifacts like that in your weld, and your welds look more like this with a little bit of the straw coloring in them. Okay, so to answer the question that I posed to you guys at the beginning of this video, can you weld exotic materials with a sub $600 welder? And that's a little misleading, because this welder's right at $5.99. If you use my discount code MOREFAB when you check out, you'll get another 10% off of that. And then the foot pedal, so you probably end up around $650 for this welder with the foot pedal. And then, you know, you're buying your consumables and everything else is going to cost you a little bit of more money. So let's just say sub $1,000. This welder, with all of its setup, all your consumables, all of your materials, all of your filler wire, your tungsten, your cups, your gas lens, everything else is going to cost you under $1,000. So yes, absolutely. You can weld titanium, stainless steel, whatever your little heart desires with a DC TIG welder is what you're going to be able to weld. Now, a lot of it will boil down to technique. This particular machine has a really, really nice stable arc. It's got a really snappy high frequency start, which I think you probably hear it at the beginning when I hit the foot pedal and you hear that initial pop. It's got a real nice stable arc start. So overall, it's a great machine. And for the cost, I mean, you guys have all seen me use my big machine. My big machine was over $4,000. And this machine being, you know, less than a third or less than a quarter of that cost is just impressive. You know, it's amazing to me that a machine like this, you can have a full LCD screen, you can have all the capability that you'd ever want, and the price point is right there. So it doesn't make any sense for you guys to buy anything super expensive if you're just starting out. So I can say, though, that before you start TIG welding and before you even buy a machine, watch videos like mine, watch videos like weldingtipsandtricks.com, watch the fabricator, his name is Justin as well. Watch all those guys. Find those guys on the internet and watch them because they're incredible. Justin from the Fabricator series, he's actually out in Las Vegas and he's got a school where he teaches people how to weld. Jody from weldingtipsandtricks.com, he's a phenomenal teacher, phenomenal instructor, and an incredible welder. So you're going to learn a ton of stuff from them, and I'd be lying if I said I didn't learn something from them every time I watch one of their videos. So the more that you know about the theory of welding, the better off you're going to be. The more that you know about the initial setup, what kind of materials you're going to be welding, what kind of consumables you need, you're going to be better off. You're going to set yourself up for success. If you just buy one of these welders, you use the out-of-the-box consumable kit, which I don't have right here, and you think that you're going to get welds like what I just showed you on stainless, you're not. You're not going to get that. They're going to be grayed out, they're going to be functional, but they're not going to look good because you don't have the proper amount of argon coverage, you don't have the proper amount of, you know, whatever it may be. You're not going to be able to get welds to look like that. So you're going to have to spend a little bit of money, do your research on your consumables. I use Fura cups for pretty much everything, including aluminum, stainless steel, titanium. Everything that I weld has some form of cup from Mr. Michael Furick himself. So that's a really, really good way to go. And overall, my thoughts are yes. You can absolutely weld exotic metals with an inexpensive welder. We just proved it. So go over to YesWelder.com. Check these guys out. They have all kinds of different welders. This is the YWT-200DC. I can highly recommend it as a great TIG welder. I do recommend you buy the foot pedal with it, though. Otherwise, you're going to be disappointed trying to use the torch switch. And the one thing that I don't like about this welder is the size of this torch. I mean, it is literally like a MIG torch. And I tend to hold these things like a pencil, and this one doesn't really fit my hand all that well, but what we can do is I'll show you. This is a CK Worldwide torch. This torch is extremely easy to hold, extremely small, and works much better for me. Now, some people may like the large handle because they hold it like they're, you know, going to hammer with it, but I personally don't like the large size of it. But I'm sure you can, you know, you can change that if you really want to, because these are interchangeable DINS connectors. So super easy to change. You just quarter turn twist and you're good to go. Or half turn twist, whatever it is. But DINS connectors on everything, so you can change the torches around and make it how you want it. Overall, right out of the box, it's a great machine. So head over to YesWelder.com, check them out. Make sure you use code MOREFAB when you do check out. You'll get another 10% off. These guys run sales constantly, so keep an eye out for that, because you could potentially get the sale price plus the 10% off, and then you'd really be in it for a while. So, all right, guys, that's it. I'm going to keep rambling forever and ever if I don't cut it here. Thank you so much for watching these videos. I hope you guys learned something from it, and if you want to see more of this style of content where, you know, we're doing a little bit more instruction versus actually just showing you a welder, showing you what welds, and then having you go buy it, let me know, because I'm currently actually teaming up with YesWelder. We're going to be bringing you guys some instructional videos on how to weld various types of materials and whatnot. So should be interesting. Stay tuned to the channel. You guys will get to see those. And hope you all have a wonderful Christmas if I don't see you, which I might not. Depends on whether or not I make a video. And, you know, stay safe. stay safe, stay welding, do all the things that you want to do. And I will see you guys on the next one. Have a good night, everybody.